Powering Africa with open tools, open source tools, PyPSA-Earth and OpenStreetMap for sustainable energy planning. Okay. Already you've seen Tosin, you've seen Mwiche, and I'm Emmanuel. Tosin is a project manager, I'm an energy system modeler, same with Mwiche. We work at Open Energy Transition. So what is Open Energy Transition? We're a non-profit and software company. We are committed to accelerating the global transition to 100% renewable energy by championing transparency. So we are very big on open source. We are big on promoting the open source tools to become the new normal. So like I mentioned earlier, what we currently do, we perform reproducible energy capacity building in these tools. Basically, our clients and partners include system operators, universities, some at Stanford, Deloitte, Google.org. So this is supposed to be a workshop, actually, where you're supposed to come with your laptop. So we have a starter kit. In some few minutes from now, we'll be doing like a demo, like a workshop where you're supposed to follow along. We teach you how you can do some mapping, basically. So if you want to follow along, if you're with your laptop, you go to this website, that's MapYourGrid.org. Just follow the instructions there. You click on the starter kit tab, click on this, then there's some instructions there that you can follow. This will get you enough, like get you started, so that when the workshop starts, you can follow along closely. So the problem in Africa here, there's this big gap when it comes to electricity. We have this wide, like over 600 million people lack electricity. Like, they don't have access to it, and this is Africa. One of the other problems is we have weak grids, we have poor data. Of course, we know we have bad infrastructures. Also, when it comes to energy planning, the tools that are currently being used are proprietary and they're very expensive. They cost thousands of dollars just for one license. And they're also closed off, which means they're not open source. You can't access them. Whatever is being built with them stays to them. You don't have access to it. There's also the inconsistent tool use across governments. So, so when there's a government that comes in as an operation, they have their guys that comes in, use the tool, probably the project. When the next tenure comes in, what happens to the project? Everything just goes away, and they have to start all over. So there's that issue. And the last one is when it comes to planning, when it comes to local communities, they are not usually considered in this planning. So I have a map here. I think I don't know if it's quite visible, but what the map is supposed to show you is, so this is a night light, where lights indicate access to electricity all over the world. But I don't know if you could see Africa. There's really not much light there, which means that we are lacking, there's serious lack of electricity there. And on this map, we have two maps. So the first one is from Google Maps. The other one is from OpenStreetMap. So OSM, OpenStreetMap, I'm going to be talking about that a lot. So on the other map, you could see, all you could see is just maybe some locations. There's nothing there. That's what planners usually see. So imagine using this map to plan. Obviously, you're not going to be able to plan well because you're obviously missing on some things. And what we have here is the transmission grid data for Nigeria. So you can see it's actually really, really, really mapped. I mean, for Nigeria, it's quite good. So now, why open tools? I mean, we could just, maybe someone just go ahead and create another tool and use. But like mentioned, proprietary energy models are very expensive. The tools are very expensive. So there we have PyPSA-Earth and OpenStreetMap, the tools that we are going to be talking about today. So why do we go the way of open tools? One, it offers transparency. So everything is transparent. The code is public on GitHub. Anybody can go there, access it. It gives room for other people to come in and contribute. Thereby, you're creating a community. And with that, there's room for validation, like to verify everybody's work. You could reproduce everybody's work. So now to PyPSA-Earth. We've been talking about PyPSA-Earth. We've been talking about PyPSA-Earth. So what is PyPSA-Earth? So PyPSA-Earth is a flexible Python-based open optimization model to study energy system futures around the world. So the keywords there are Python, model, energy system futures. So you're trying to plan what is going to look like for the next 30 years, 2030, 2050, 2070. Do we want to have more solar? Do we still want to be using coal like we have here in Lagos? So this is where PyPSA-Earth comes in, and it is open for everybody to use. So it is one of the most widely used tools in the world, with over 500K downloads from PyPy, in case you're wondering how we got that. Like I mentioned, it is fully open, so there's no licensing cost. I mean, zero licensing cost. So coming from where you have to spend 1,000, 100,000 to obtain one licensing cost, to a platform where there's zero licensing cost. I mean, that's a lot. It is data-driven, so all the data that is being used in PyPSA-Earth is open source, like open data from weather data to topography, which is where OSM comes in. That's OpenStreetMap. It enables long-term least cost energy system planning. So like I mentioned, you could use PyPSA-Earth to plan for the future, but when you're planning for the future, it allows you to consider the least costs when you're planning. So what is the least way to plan this, to make this work? Here is a GitHub star. I'm not going to talk much. So we have other open source models, open source energy models, but this is how PyPSA-Earth ranks among them, sorry. Yeah, so you can see how PyPSA-Earth ranks. So what can PyPSA-Earth do? I've been talking about PyPSA-Earth. We've seen the things. You can generate network topology. That's your network, your grid data to see. You could simulate hourly electricity demand and supply. So just to put context to it, the hourly electricity demand basically is you take a year. In a year, you start from the first hour in the year. So it's more like what's the demand for each hour across the year. So right from the first day, the first hour, the second hour, what's the demand like? Then also you could use PyPSA-Earth to build models for each region. I mean, if you're in Nigeria, if you want to build for Sudan, if you want to build for somewhere else, or if you have a grid, like a mini grid in your area, and you want to do this, you could use PyPSA-Earth. And you could generate data, right? Your weather data in time series, renewable energy potential. So for instance, this is a location. We want to know what is the renewable potential for solar here. Is it going to be better to install solar here or install it 5 kilometers away? What's the potential like? Which is better? So that's where this comes in. Here is a workflow diagram. So earlier I mentioned PyPSA-Earth is more of data. So everything is data processes. We have several data coming in. So you can see these are arrows. You can see start from the top and end somewhere here. So all of these are data processes. So you can see, it's not quite visible, but everything here are workflow diagram. We use SnakeMake to manage. So SnakeMake is also open source in Python. So we use that to manage the orchestration. So right about now, we're going to talk about transmission grid mapping. And I'm going to hand it over to my colleague, Mwiche. He's going to continue from here. So, Mwiche, up to you.
Okay, hello everyone. As already stated, my name is Mwiche, and I will be talking about transmission grid mapping in OpenStreetMap. Yeah, so my colleague has already touched on the fact that you need transmission data to go into the modeling. This is the geographical data that PyPSA uses. So, but then PyPSA being an all open source product, it relies on open data as well. And that necessitates why we have to talk about contributing to OpenStreetMap, the transmission grid data. But before I get started, I'd like to first start from the basics. What is a transmission grid? Just so that we are moving on the same space. Do we remember? Okay. Yes. Anyone else? Okay, so transmission grid is simply a network of power infrastructure that moves electricity from the point of generation to the point of use. Similar to what you have with water, you have a pipeline, right? You have where the water starts from the dam, and it's processed, they clean it up, and then it's served to the people that use it. So in our case, we have the power generation point, which can be any energy mix, either thermal, hydro, renewable energies, and it goes through a series of processes, like through a series of infrastructure. A huge part of this is the transmission infrastructure, where you have the power towers that we see, and I'm sure we could have noticed some of this on our way here. And then once it moves through the transmission infrastructure, it goes into the substation and then ultimately ends up to the end user, just like you and me. So this could be in industry, this could be in a facility just like we are using right now. Okay, and I'd like you to pay particular attention to this, because when we start talking about transmission grid mapping, these are the infrastructure that we'll be adding to, right? So the importance of the transmission grid is that it enables connectivity. So like I mentioned, this is a network of infrastructure that is moving electricity from point of generation to the point of usage, right? And also, because it is moving from point of generation, it also means that it integrates a lot of renewable energy sources. That is another advantage. And the other thing that you can use this transmission grid for is that it can be used to serve critical infrastructure, such as hospitals, schools, anything that we need. So from this, we can see that transmission grids are actually a very key component of our economy today. Every country, wherever you are, this is a very key component, right? And also, in the context of what was started by my colleague, having information on the transmission grids also enables energy planning, right? So this is useful for governments, institutions, but also for third-party individuals such as you and me, who may not directly be affiliated with the government, right? So once we have this information, we can plug it into models such as PyPSA-Earth or whatever open source model, and a lot of fun fact, a lot of open source models actually rely on this data, right? And so energy planning is a very key thing when it comes to having this data. But then how does someone not affiliated with the government like you and me gain access to data about transmission grids? And that is where now things get tricky, because it's really, really difficult, right? So across the world, there's actually a huge gap of transmission grid data. A lot of this information is missing. Governments do not openly outsource this, sometimes for security risks, and it's not even security risks, sometimes they're just worried, you know. But this information is really difficult to get a hold to, either for licensing reasons or something like that. And so Africa being a huge part of the world's population, we form a huge gap in that, a huge space in that missing data worldwide. And so if you look on the right, this map shows the EMBA Africa Data Transparency Report of 2022, which shows on a scale of 0 to 5, just how openly available electrical data is by country. So you've noticed that a lot of the world, mostly in the eastern part, has zero availability of this information. My own country, Zambia, actually has that as well, and as Zambia, I can testify to that. Nigeria falls on a scale of 1. Yeah, so we have a long way to go as well. And so if we go down, if we zoom in further, we notice that how was this scale arrived at? So this is how it was broken down in the report. We have the publishing lag, the time granularity, the fuel breakdown. These are the different metrics that were used to arrive at the value. And we see that while the data is published regularly in Nigeria, and the time granularity is good, it's a week or better, the parts where we really fall back is on the fuel breakdown. A lot of this data is actually high-level data, which makes it difficult to generate key insights that you need to make proper energy planning as a third party, right? And so the other thing that I'd like to point out on this, and you can get into the paper later, is access to the data. We notice that ease of download of this data is actually at 1. So that is also a huge challenge. On top of everything, it's difficult to get this really high-level data altogether. And so that creates a problem. But if I come back to this map, we see that of the entire continent, the UN countries within Africa, only South Africa comes close to an almost perfect score, right? So this is a value of 4. And so one of the things that South Africa did is that they actually just bought high quality satellite imagery and made it available for the South African country. And once this was done, it was now left to the community, people just like you and me, to improve the grid. And so what we see is that here's a picture of the transmission grid within South Africa, taken from OpenStreetMap, and we can see that a lot of the data is actually mapped. And this wasn't done by the South African government. All they did was just make the satellite imagery available, and the community went to work. And so this is something that we can push for policymakers that are available to just make the data available, make the satellite imagery, and the community can take it up from there. Because one of the things, and once we get into the mapping, one of the things you'll notice is that Nigeria actually has really bad quality data, satellite imagery in OpenStreetMap. It's really difficult to perform mapping. And so after showing all of this, the question you may ask is, how can we close these gaps? How can we make improvements, right? At this point, this is now we start to talk about open data and OpenStreetMap, okay? So what is OpenStreetMap? OpenStreetMap is simply a free, open, and editable map of the world. So being a map, it has layers on everything. You have roads, you have schools, you have churches, anything of interest, right? And in this particular case, we're talking about transmission grid data, right? So anyone can go into OpenStreetMap, select a layer that they want to contribute to, and this can be done freely. It's driven by the community, which means people like you and me. And also, OpenStreetMap is not something that is like somewhere hidden to hobbyists. This is actually being adopted and used by international bodies such as the World Bank for their own data, right? And there are sources available for that. And so, over here, I don't know if we can just maybe... The lighting is not so clear, but over here is a side-by-side comparison of OpenStreetMap data and Google Maps imagery, right? So on the right, we have we loaded the electrical grid data for Lube in Abuja, and we see that there's a transmission line over here, a 330 kV line, and over here we have some key power infrastructure, which is the power towers, over there, and we can see the path of the line, and the line also has some key metadata, including the voltages. But in comparison, when we look at an extract from Google Maps, just like my colleague had said, it's difficult to make sense of this information unless you're just using it for navigation. You can't tell that this picture is the same picture here because you can't see where the line passes, which is not so clear, except if you've been doing mapping such as myself, because I can tell that there's a power tower over here and the same power tower here, but beyond that there isn't much. So what else can you map within OpenStreetMap? So another key infrastructure that you can map is substations and power plants, right? So this is the Sapele power plant in Delta State. So you can see the same transmission lines coming in. The red circle represents the transmission substations. You have the power plant over here, and you have a boundary over here, the fence boundary. And so, again, this is really rich information compared to just ordinary satellite imagery in Google Maps, right? So this is something that you can do within OpenStreetMap. And I will get into that later in detail. So the other thing that you can do to contribute to this data is that OpenStreetMap, mapping in OpenStreetMap can be divided into generally two things. So you can either just annotate the map, which is similar to what has been done here, where you just draw on the map literally, and then you end up with this infrastructure. Or you can do what is called technical mapping, and technical mapping further makes improvements by adding key information such as voltages, capacitance, resistance, and all of that. These are information that are critical, as mentioned earlier, for energy modeling. And so, but then before you get started with this technical mapping, you need to understand the two core principles of OpenStreetMap, which is that for stuff that you can only map stuff that you see from satellite imagery. If you can't see that, for example, voltages, looking at the satellite image, you can't really tell what the voltage is exactly. You can estimate, but you can't really tell. So OpenStreetMap requires us to use publicly available data whenever we're dealing with metadata, right? So make sure that the data that you're adding to OpenStreetMap is publicly available. It can be referenced clearly. And also, when dealing with physical properties, make sure it's information that is only made available by system operators, right? So that is very key. And so people such as you and me came up with a community, and so this is where the MapYourGrid initiative came in. Building off of the same principles of collaboration and community, the MapYourGrid initiative was formed by OET with the goal of increasing the the transmission grid coverage globally from 70% to 98% in just 2028, which is 3 years, right? And so I have over the next few slides some of these contributions, starting with Nigeria. You see the black lines, which I'm not sure if are so clear. This was the state of the grid in OpenStreetMap prior to the initiative. Then you have the orange lines. All of these were added by the MapYourGrid initiative, people just like you and me. And then there were also other people outside of MapYourGrid who can also be represented in green. And then if we move on to the continent, you see the contributions as clearly depicted as well. You have all the orange parts being the contributions done by MapYourGrid, which is a huge improvement to the data made available at continental level. And then also at world level, the purple lines, the same, indicating contributions by MapYourGrid. Another key thing that can be done with OpenStreetMap is that you can create really good data sets such as the power grid connectors, which is what can be seen from this map here. So the purple lines show the contributions that we did, and power grid connectors are simply lines that connect electricity from one country into the next. I'll give an example of Africa, which has communities, electrical communities called power pools. They are in the southern, western, eastern, and so as those communities are trading in power, the connectors really come in handy. And so knowing where these are is a huge bonus to not only system planners, but governments as well. And then once you have this data, what can you do with it? So when this data goes into PyPSA-Earth, it is cleaned, and PyPSA-Earth is able to create networks that support energy modeling. And so you can also build realistic transmission and distribution networks, as already mentioned. And PyPSA-Earth also does mini-grid modeling using PyPSA-Earth distribution. This is something that my colleague touched on. And the next slides just show examples of these solved networks. So you have the model for Africa, for Nigeria, and this is after PyPSA has processed the OpenStreetMap information. Then you have, and these are studies that have been done across the world. You have for Zimbabwe, for Sudan, as well as for Zambia, something I'm very proud of. So a call to action to everyone present to just be a part of the community. Let's build transparent Africa and own solutions, because no one else can do this for us. be a part of the community, learn the tools, and I will quickly now jump into the workshop to show you how you can actually, how these tools actually look like with the demo. So for the demo, what you're going to need is two things, right? You're going to need, first of all, a web browser, and then you're going to need a tool, an editor, because you need to make changes to this data. So the editor that you're going to use is a tool called JOSM. Okay, this is very smooth. Okay, yeah. So JOSM is what you're going to use to make changes. You're going to load the data into JOSM and make edits to it. So to get started, you go to your browser and you just type in MapYourGrid.org. Very creative name, by the way. So when you come to the MapYourGrid website, you will notice that there are several tabs that can be seen from the website. And so to get started, you just click on the Map It section. And the Map It section will show you different tools that we created. And I will touch a bit on the whole interface, but the parts that you need to know is that on the first part here, which is the transmission overpass query. So overpass is simply an SQL-like language that OSM uses to query the database, right? So you can pull filtered data with your own specifications, and these buttons that you see over here are optimized queries that we created to just help you get started. So the default transmission button just pulls transmission grid data above 90 kV. Then at the bottom here, you have hint layers, which are just tools to help you spot inconsistencies in the data. You have quality control tools, likely positions of power plants, and so on and so forth. So to get started, there's this map over here. And what you do is you just click on the country that you need to get started mapping on. In this case, we're looking at Nigeria. So once you've done the setup that my friend spoke of in the starter kit, the moment I click on Nigeria, a prompt shows up, and the data, you're greeted by that dialog that shows you that the data is starting to download. So for the sake of time, I already loaded this data, and I will not wait on this. So here's the data. You have on the right the layers pane. So this pane shows you the three layers at the bottom. These are satellite imagery, and you can actually cycle through this or just turn them off altogether in case you want to just look at the pretty lines. Yeah. Then you have the data layer at the top given by the country name that we're looking at. And so if I zoom into Lagos, right? If I zoom into Lagos, we are somewhere over here. Is it okay if I can get like a book? The surface is quite smooth. It's difficult to move the mouse. So we have the Lekki area on the map here. And so if I zoom out for a bit, we see this is the transmission grid that was clear in my friend's presentation earlier. And so the color coding shows you all the different voltages of these lines. You have the really high voltages. In the case of Nigeria, these are 330 kV. You have the 132 kV, and then you also have lines that are lacking voltages. These are the white lines over here. And then you will notice that some of these lines have a circle at the end, or a bubble. So the bubble shows the positions of substations and power plants. So for a complete grid, as depicted here, you want to ideally have all the lines having bubbles at the end, because then you have a connected grid, right? And so if I zoom in into, say, for example, here, so we have a transmission substation, we have 132 kV lines. So we have 132 kV lines coming in from the top. We have the 330 kV lines coming in. And if I cycle through the data, through the satellite imagery, I can see that this is actually quite, okay, the data is loading, yes. So I can see just how clear the information is. Let me see if I can find a power plant as well. Should be over here. So this is Kukwawa substation, and also I had a drive yesterday around here, so you can also see once you go past Admiralty Way, somewhere right here in Lekki, you can find Ikoyi substation. I actually took notice of this one. So you can find Ikoyi substation. This is the substation that we were looking at yesterday. You have Ijora substation over here, and this is the power plant. So now I will get into actually mapping a line. And so I bullied my friend Emmanuel to give me the location of his house. I will not share it for security reasons. But he mentioned that there was a line that he suspected around his area which may have not been mapped. And so I will quickly jump to that position to just show you how mapping is actually done. So we just input the coordinates and we click jump here. Okay, so here's the location of somewhere in Nigeria where my friend lives. And like I mentioned, you can notice the quality is so good, you can actually almost see him eating some jollof somewhere along there. So as you move along the line, you can see here is a power tower. And as you move, you can see what appears to be another tower over here. And what they look like is almost like cones. For this particular one, maybe we can turn off the light to just have clear. Yeah, so you will notice that they almost look like cones because of the positioning of the sun falling on the towers. And one other thing that can help you determine when you're following a tower, and here's a really good one, you can see the actual tower over here and the shadow of the tower on this side. So to get started, you just click on this button here, which is the draw node button. And once you click on it once, you set a node. Then as you move, we start looking for the other tower, which is over here. You will notice that in OpenStreetMap, this line is called the way, and it's used to annotate anything straight, a fence, a road, whatever. And in order for you to know that this line is actually a power tower, you click the presets over here and convert this line into a power tower, into a power line. And this converts to white, as stated earlier. So as you go further, so we can extend this line to here, here, here. And notice that, like I mentioned, the period is actually quite regular, and that's how you know that you're actually following a line. So as you move, we find another line here and another line here. So the line actually goes a bit further, but I will end it right here because I also want to show something else. So this is the line that we've contributed. It's a small portion, but it's good for illustration. So the other thing that is key before you upload this information to OpenStreetMap is that you need to specify these nodes as something, right? They need to have tags. So you will notice that if I click on this, in this part of the pane, it shows you what type of thing this is. This is a power line. But if I click on the nodes, OpenStreetMap doesn't know what that is. So we need to tell OpenStreetMap that those are actually power towers. So if I enter this command, and you can find this on the website, I can click the presets and tell that this is a power tower, and you can notice that the line actually changes. So at this point, you're done, and the next thing that you need to do now is to just share your information to the server. So you click on the green button at the top here, wait for it to do a bit of quality checks. Just click space, leave the MapYourGrid hashtag. This helps support the initiative. And enter a useful comment. So this comment is similar to a GitHub comment, right? And so the other thing that is important is you have to specify your source of data. So in this case, we used satellite imagery, Esri imagery, which is what is here. When you click here, it picks automatically from the editor. Then the last thing that you have to do is to click on this button here, which requests someone to review the changes that you've made in OpenStreetMap. So once that is done, you just click on upload, wait for the change set to be shared, and voila. Yeah. So it's as simple as that. It's as simple as that. So anyone can literally contribute to OpenStreetMap. And so I encourage everyone to just join the community as shared. We are actively mapping. We offer free training. And yeah, just visit the resources, and you'll be able to find all the data that you need. Thank you. So at this point, I will just accept any questions.
So you showed information about power lines, but do you also have things for like solar and things like that too?
Yes. Let me just quickly come back to OpenStreetMap. So if I zoom in into the Lekki area, right? Over here, we see Eco Atlantica solar farm. So you can actually find that. Yes?
Yeah, so thank you very much for the talk. It was so much enlightening. So I would love to ask, are you pushing any agenda to the government to probably provide solutions to power issues in Nigeria? For example, maybe after mapping, I'm living in an area, or I know about an area that the grid is down or something that is affecting their lights. Is there anything that you can do, or all you do is just to map one power source to another? Is there any policy pushing to the government or any solution being provided for the power issues that we have generally in Africa and Nigeria most especially? Yeah, thank you.
Okay, I will call on my Nigerian counterpart to talk on that.
Thank you for the question. So we are doing a lot of work to work with the national energy agencies here. So like NERC. NERC is a National Electricity Regulatory Commission. So we're in talks with them to encourage them to use open source planning tools, because that's very useful for us to support long-term energy planning. I know now, most of you know, in Lagos now, we will not be having power for, I think, the next 1 month, because they're upgrading the systems. Yeah, there'll be some intermittent power for some hours, I think from 8 a.m. to 5 p.m. There will be no power because they're upgrading the systems. But with open source planning tools, that's very useful to ensure that we're planning sustainably and we can tell, how best to support energy long-term here in Nigeria. So there are plans underway. It's not just mapping. Thank you.
And also, to just add on to that, in my own country, the companies actually signed an MOU with the electricity provider, Ministry of Energy, to offer capacity building in energy modeling, and also to just offer support in planning their energy future. So once we have this is just bettering the data, because as you know, garbage in, garbage out, no matter how robust the model is. And so once we clean up the data, we make it viable, then we go to the people that can actually use this information. So we're doing it in Nigeria, we're doing it in Zambia, and soon we'll be going out to everywhere. Any other questions? There's a question there.
Okay, thank you. I want to ask about contributions and contributing to the platform. So how is it like? Is this just by connecting grids, or what's the contributions like? What are the contributions?
Okay, that's actually a very good thing. So For starters, we encourage community contributions. There's a lot of active mapping going on internally. And so you can get started by just scanning the links, joining the community. And then we have listed a map. And this map, this website curates all the knowledge that we've gathered since we started. Because contributing is actually a bit difficult. There's quite a learning curve to using OpenStreetMap editing. And so all of that information can be found at the MapYourGrid website. So you can read up on it, get familiar, and you can also schedule, you can also look at the meetings that we're having and just join in. Say hello, we are most welcome. Yeah, so you can do it independently, but we do encourage community. Yes. And we also have some nice stickers to show that you're part of the community. Yeah. Okay. There are any other questions?